Um, today's class, we're going to do HTML stuff again, but with the concept of server. So last time when I did it, I only showed you the front end, which was the HTML, CSS, and JavaScript. Now, while just that can achieve a lot of things, you can't make it to fetch data and show other pages efficiently. So, so I'm going to show you a server-side script that's written in Python. Right. Okay, so before I begin, let's try some stuff. Go to this right side and do exclamation mark and do ipconfig. Now, if you're a Mac user, the command is ifconfig rather than ipconfig. Okay. Okay. So I have a few other things because I also have a VirtualBox installed. Okay. So it's a bit hard to see which one's your IP address, but something that starts with 10, that's a local IP address. So one thing that you have to know is that IP addresses locally start with either 10 or 192. So if you see IP addresses that start with 192.168, those are not like IP addresses of Google or some other websites that you visit. It's something that's local. Same thing for 10.0, okay? All right. So you're going to see this. And what's an IP address? IP address is a series of 4 numbers with dots in between them. And these numbers are from 0 through 255. So I just realized that some of you do not know what binary numbers are. Binary numbers are, it has only 1 and 0. So 0B, 01. 0B, if you start a number with 0B or capital B, either one of them, that means that you're telling Python that I'm going to write a binary number. And if you put that, it's same as 1. If you put 10, that's same as 2. And if you add 0, 1, and 10, what would you get? You would get 3, right? And so 0B11 is 3. So what do you think 0B100 would be? Each placeholder goes by powers of 2, right? So this is 1's digit, this is 2's digit, and this one is 2 squared's digit, which is 4, right? So this is going to be the same as 4. And then you could also have something like 1100. And what would that be? This is 2 to the 3rd power. This is 2 to the 3rd power, and then add that to 4, which is the next one. So this is going to be same as 12. All right? Yes?
I thought in binary, like, 1 was supposed to be 0, 0.
No. 0, 0 is 0. Okay? Yeah. Okay. So if you have 0B 1111, 1111, okay? What would this be? Well, it's hard to do it in your head, but think about this. If you add, the thing is, Python automatically detects it changes to binary, but if you want to stay binary, then you need to put bin for it. Okay, so that way it will give you the string in that form. Okay, so let me ask you this: if you add just 1 to this binary number 11111111, what would that give you? 1 plus 1 will be 2, but that's going to give you a carryover, right? And that's going to add a 1 in the next digit, which will again do a carryover. So it's going to turn everything to 0, and then finally you're going to get a 1. So this is going to be same as 1. It's sort of like in a regular number, add like 99999999, and you add 1. What happens? There's all the carryovers, and you get zeros, and that's what you get, right? So the same thing happens in a binary because you only have two numbers, 0 and 1. Okay, so now let's think about what this number is in decimals. So you have 8 zeros, so that means this number will be same as 2 to the power of 8. What's 2 to the power of 8? 2 times 2 times 2 times 2 is 16, and then another 2 times 2 times 2 times 2, which is 16. 16 times 16 is 256, yes. So you get 256, and because this is 1 less than 256, this number would be 255. Okay, that's where this 255 comes from. So we're talking about the when we are making the game Spaceballs, we were talking about how the color RGB channels go from 0 to 255, and 255 comes up a lot in computers, and it seems so arbitrary. But so if you were wondering where that number comes from, it really comes from the fact that if you have an 8-bit, which this is called 1 byte, okay? So computers store, the smallest memory space a computer stores is 1 byte, okay? So if you hear that, oh, I have a 1 gigabyte of RAM, which is not very much these days, but let's say if you have 1 gigabytes of RAM, that means you get, let's see, 1 kilo is 1,000, 1 mega is million, 1, right? Okay, so 1 billion bytes can be stored in a 1 gigabyte RAM. Okay? Yeah. And each byte can store numbers between 000000000 to 111111111, yeah, which is 0 to 255. That's why this 255 appears so many times. Okay, so if I convert this, not to be, if I just write this in, it's going to say it's 255. Okay. All right, so that was just a quick introduction to binary numbers, and as you can see, these numbers 255 comes up a lot. Okay, and the default gateway is where all the okay. So let's see. Here, 10.0.50.2.181 is my computer's IP address, and then this one would be the gateway where the information is sent. So there are like 255 computers that's connected to this one, I would say, ring of computers, and they can they get this data. So what happens is when you browse the internet, you ask some data from the server is going to send a packet of what is that? So it's going to give you a packet of data, and that packet is going to be really sent to all the computers, and only the one that matches the exact IP address is going to actually receive them, and the other one is not going to ignore them. Okay, and this one, the subnet mask tells you what's the size of this network, and if it's all 255, 255, 255, and then only 0, that means the network size is 255, 256. Well, actually, 0 and 1 are reserved, so it's more like 254. But anyways, that's what you have. And then if you have 1 there, that's like twice as much. So in my network, there are 512 computers connected to this default gateway. Okay? So that's what's happening. All right. So I want you to do some activity. I want you to try. Oh, I already told you to do this. Okay. So ipconfig. If you're on Mac, please try ifconfig and find your IP address. And then at the same time, I want you to go to Google or Firefox or whatever your browser is. And you're going to go type in, what is my IP address? Okay. You're going to click. Okay. So, did you get the same IP address as mine, or is it slightly different? Slightly different? Okay. How much does it match? Exactly. So yours match exactly. How about the other ones that do not match?
No, mine is the same.
Oh, exactly same?
Yeah, but it's a different, way different location.
Oh, okay. Yeah. So everyone has the same IP. You have a different one?
No.
The same. Okay. So everyone has in this classroom has the same IP address. And why is that? Well, so the reason that the IP address is same is because in the world there are many, many more computers than the IP addresses. Like, think about it. It's 256 times 256 times 256 times 256. What is that? I can't, so 256 to the fourth power. Yeah, that's 4 million. Okay, so this is 4 million. This is 4 billion. Okay, so there are 4 billion IP addresses out there. A lot of these are also restricted. So some of these are restricted for special purposes that's not being used. And as you've seen, some are reserved for gateways and other things. So not all of these are usable. I don't exactly know how much of this is usable, but 1 billion addresses is not going to address all the computers that we have in the world that's connected to the internet. So you might wonder how that can be that each computer would have their own IP address, because without the IP address, when you browse the web, when you ask the server to serve me this web page, when the server sends you the HTML, it's not going to reach you because it doesn't know your IP address. That would be bad, right? And what actually ends up happening is with the IP address, there's something extra called ports, which is another, is it 256 squared? I think so, yeah. No, not times 2, but squared. Yeah, another this much number of ports that you can use. And what it does is when the server sends the message to the IP address with a certain port, then there's something called the NAT. That's called Network Address Translator. It takes in that information and it translates the IP address plus the port number into a local IP address. So that's why there's a difference between your own IP address with the external IP address. So everyone in this school, if you're connected to the school network and accessing the outside world, they're going to see that there's somebody in SUNY Maritime College that's using this page. Okay, they wouldn't know exactly who's who. Like, it doesn't know exactly which computer inside the SUNY Maritime College is going to be accessing this one. Okay, unless they have access to the network address translator itself. Okay. All right. Now that means there's a problem with having a server. So long time ago, we didn't have NATs. Long time ago, when computers were more scarce, like in the early 2000s, IP4 was plenty. Okay? You could address every computer, which meant that you can allow any computer to be the host, serving something, okay? And other people could reach it. Now, because all the computers are behind the NAT translator, you can't host a web page on your own computer because other computers wouldn't know how to reach it because it has to go through NAT. NAT therefore serves as kind of a security measure because outside hackers would have harder time trying to get into individual computers. If a security expert hears what I just said, they're going to freak out because there's so many other things that the hackers can do. But it's like the most basic kind of security that you shouldn't trust, but it's there, okay? That's what NAT does. All right, so the reason I'm doing all this is because, unfortunately, while it would be wonderful to have a server hosted on your own computer and ask other people to get onto your web page, that's not going to happen, okay? The most you can do is make a server on your own computer and access it from your own computer. That's all you can do. Maybe because you guys are all using the computer lab computers, this might be able to access other people's. The thing is, I'm on the faculty network, so even among us, we don't have connection. So and I believe the network is structured that the students have something like 6 or 8 different networks. So when you go on Wi-Fi, even if 2 students log on the same student Wi-Fi, you might end up in a different network. But it's likely for this lab to be on the same network. So, Noah, what's your IP address? The local one, 10.0. Yeah. 10.0.10.49. Okay. So I'm going to ping it to see if it responds. I don't think it responds. All right, it's not responding. Yeah. But can other people try this? Ping 10.0.10.49. Okay. So this local network address. Oh no, you can't do it your own. So yeah. Hangi, what's yours? Yours is 48. Oh, okay. So you guys should be able to ping each other. Can other people ping?
I didn't pick my own.
Oh yeah, but it doesn't mean anything. You can ping your own, right? Can you ping hers and then could you ping his? What did you get when you ping?
It's loaded.
It's still loading. Okay. Oh, you got nothing? Lost 4? Everyone just have sent 4. Oh, okay. So, that means that the network here, the IT people blocked the network setting for the ping. There's a separate ping server that responds to pings, and that's being blocked. If you allow connections to be easy, then there are several ways that the hacker can go into other computers and do things. So it's not surprising that has been blocked. But if you're on a home network and if you have 2 computers, look at try this. You just look for the IP config and try pinging one computer from the other, and you'll be able to see that you can do such a thing. So, for example. I was trying to help out my wife's project. It was like a huge number of data that had to be processed, and because one computer was too slow, I had to divide the work to several computers at my home. And to make it work, what I did was I installed Linux on these computers and installed the FTP servers on each one of them. So by using scripts, I could send files over these SSH or other kinds of protocols to the computers, and these were done automatically. I didn't have to copy files on a thumb drive and put it. By the way, thumb drives are much slower than actual networks. Networks, if you're inside your home, is very fast. So that was the way I could distribute the computing, and then I had a cluster computer at my home. You know how these big cluster computers work? These are supercomputers, but not only the individual computers are really good, you're connecting like hundreds and thousands of computers to work at the same time. And they share the files and everything. Yeah, so I was making a very weak powered cluster computer at my home just by having these networks set up. So it's something to try on. And once you make this work, then you can probably try to do the same thing at home with two different computers and see how you can serve one web page and do it on the other. Okay. All right, so that was a bit of a longer introduction than I thought. Okay, so now let's start by installing the Flask web server. So we're going to do exclamation mark, do the usual pip install Flask. And as I said before, if you have a Mac or Linux, you might have to do pip3 install Flask. Okay, so mine is all satisfied. Are you guys still installing? Okay, let me wait for people to install. Yeah, another security feature these computers have is that I can do cmd enter and write all these things like ipconfig here. But yeah, so I can also do something like trace route google.com, and it kind of like looks at different ways to go through Google, because if I make connection to Google, it's not like you get immediate connection. You have to go through several computers to get there to the Google. It's saying request time dot. I don't know why that is. Maybe even the trace route is locked. That's strange. All right, but anyways, what was I trying to say? Oh, yeah. So one of the security features that the computers in the computer lab is that you can't do CMD here. It's blocked by the administrator, so that you can't easily write hack codes. But you can execute all the command line codes here. So that's what I'm doing here. Okay, let's see. How many of you got it installed? Done? Okay, everyone's installed. Okay, good. So everyone seems to be installed. So now let's start out by writing a new code. So here's a new code. We will always import larger from Flask. Import Flask, and then we will also do request. We're not going to be using request for now, but we're going to use it in the later example. Okay? And I'm going to say app equals to Flask underscore underscore name. This is two underscores, okay? And then we're going to say app.route. Okay. And then, just a minute. Okay, define hello. And we're just going to return hello world, exclamation mark, and then if name equals to main, then we're going to do app.run, debug equals to true, and that will be the simplest Flask server. Oh, it's double equal sign. I made a mistake here. Okay. So first of all, you have this, this is almost boilerplate code here. You have to import the Flask from the Flask package, and you would always write app equals to Flask of the name. Now, what is this name variable? It's the name of the program that's running right now. If you're running this as the main program, then the name would be equal to main. If you divide one single code into several parts, so that we've done this before, like we had the separate Python code that we imported that you made on your own. If you're doing it that way, that's going to have their package's name as the name. Now, why would Flask need this name? Because Flask tries to tag all these functions that are written inside each script, because they need to know which functions to execute. So this kind of gives you the tool for Flask to work with. It's like the namespace that Flask uses to address all these functions. Okay. Now, when this line number 9 says, if you're running this program as the main, then you run this app, which is this app. Okay? And what it does is Flask will now run and start listening to any server requests. So what does Flask do? It will just run in the background and not do anything, just wait for somebody to ask for a file. Okay. Okay. So going back, yeah. So it's going to run when Flask runs. It will just wait until somebody goes to that web page requesting something, okay? Requesting a response. Now, this app.route, this is the top directory, top folder of your web server, and it's saying if somebody is at the top server requesting something, this add something is something called a Python decorator. Okay? Python decorator. Okay. And what Python decorator does, it decorates the next function, and according to what this previous thing is saying. So this app.route something something is a function that decorates this other function, and what it does is it tells Flask to say, if somebody tries to access the main page, execute this function. Now, what does this function do? It returns hello world. So it gives you a text page. Rather than an HTML page, it's going to return a text page, and that's going to be shown to your browser. Okay. So now let's run this. Let's run it. Okay. It's running. It's running. And now you're going to head over to any browser. It doesn't have to be Chrome. It can be Edge or anything. And go to 127.0.0.1. And then you need to have a double colon and put 5,000. I just realized this is too small to see. So let me post it here. Yeah, let me post it here. So there's a comment. HTTP 127.0.0.1 colon, not semicolon, but the colon, 5,000. This colon 5,000 is the port number, and if you don't provide any of these, then yes, yours didn't work. Okay, we'll figure it out. So if you have colon 5,000, it will. If you don't provide the colon 5,000, what it does is it looks for port 80 automatically. That's the port for HTTP requests. Okay, and then there's another port for HTTPS secure HTTP requests. I think it's 8080. So those are like kind of the standard ports. Now, what happens is that you could very well have app run debug true and make it listen to the what is it, port. We can have the port equals to 80. Port equals to 80. Okay, so let's stop this. Control C will stop it. No, it doesn't. Sorry. In that case, I'll have to just exit and restart the kernel. All right. So just do this X to completely crash the kernel and start over. Okay. And if it's crashing, you will see that this web page will no longer work. If you refresh, it doesn't work. It just hangs. Okay. It can't be reached. Right. But now that if I start listening to the server, run it with the new port 80, then what's going to happen is you can go back and don't use 5000, just do 127.0.0.1, and it gives you the same hello world. Okay, I didn't know I could zoom this in. Okay. So if you zoom here, you'll see that Google has its own IP address, right? So what happens if you type a domain address on here? Well, what it does is when you type in google.com, it's going to go to a local server which has all the names and the IP addresses. That's called domain name server, DNS. And for fast network access, usually a big place will have your local DNS server. So our school has one or two DNS servers, and their DNS will cache all the addresses and then the IP addresses. Now, when you try to go someplace, then this URL will be sent to the domain name server, and the local domain name server will look at its cache, and if it knows which IP address it is, it's going to return this value and it's going to look for it. Okay. Now, however, if you're trying to go to some unknown domain name, let's say you just made a home page and you bought the domain name for that one, okay, then only a few DNS servers would know about it, right? So what happens is that the local DNS server will not know your homepage's URL, how to translate the IP address. So it's going to be sent to another domain name server until it finds where it is. So, but sometimes your browser will try to locate that IP address in many different domain name servers, and it doesn't, and then it will just not return anything. And there are cases where your area domain name servers don't have the address, and you wouldn't be able to have access to the web page because your domain name server doesn't know its IP address. Okay. All right. So that's what's happening. And then another thing is the 127.0.0.1 is the standard local address for your own computer. Okay, so 127.0.0.1 is your own computer, and it also has a URL. The URL for your own computer is localhost. Okay, so it does the same thing. Okay? So you can just do localhost, and it will know that it's you. Okay, but this wouldn't work if you're trying to access to another computer at your home. So if you have another computer at your home trying to access this web page that you just made, then it's not going to do anything if you do localhost, because that's not going to be your computer. So in that case, you really have to want the world to be able to access it. One way to make it available is to go to these server companies. So the one that I'm using is called linode.com. I have an account here. So if you buy something in here, you can install a new Linux computer with operating system all intact, and you can install Python, Flask, and all that. And I used to have an app on here, but I couldn't pay I didn't want to pay any more money for it, so I didn't that's not running right now, but you can very well have your own thing served to the world by using these kind of things. Another famous company is Heroku. Heroku is another cloud company. Or Amazon or Google, they have their Google Cloud or Amazon Cloud. You can make a separate server installed and install Python there to serve your web pages. Okay. All right, so I think I've said plenty. Let me just delete the port. Now, what else can you do? You can also, instead of returning one text, you can do several strings, okay? Where you can just return HTML code. So, doc type HTML, right? We saw this last time, right? Yeah, and then you can do body, and then H1 will be making it big, and hello world. Or maybe I can say, welcome to the world of Daniel An, right? Something like that, and then enclose this with H1. Right? And then P, this web page is the best thing you will ever see, yeah, best page you will ever see. Something like that. Yeah. Some cheesy stuff. Yeah. Something like that, and then we're going to enclose the body. Oh, I forgot. You have to start the HTML and enclose. Okay, so you have to do HTML, and then enclose the body, and we can also enclose the HTML. Okay, so that will be in triple quotes. That gives you multi-line strings, and that should give you a whole web page that can be processed. So let's get rid of this, and then let's run it again. And let's now go to the local host. Oh, I forgot. I changed the port to 5,000. So localhost 5,000. Right? Okay. So now you see it. Okay. All right. Now next, what other things can you do with it? Okay. So I just have like two more fancy stuff to show you. One is there are two ways that when you put some information to a web page, the web page takes that information and passes back to the server. And those are the get method and post methods. The first is the get method. Get method is when you put a question mark and put a variable to this. Okay, so let's say. Okay, let me just take this one and comment it out. Comment is a control one, I think. Yeah. So I can fetch some information. Okay. Request.args.get, then feeling. Okay. And then the second one is what the get will return if you didn't put anything there, okay? So if you do if feeling is sad, you can return don't feel bad, everything will be all right. Like that, okay? And if feeling is equal to happy or feeling good, yeah, return that's great, your hard work paid off, something like this, okay? And then if I should really do else if. Okay. If it's neither sad or good, then we're just going to say else return. Tell me how you feel. Now, a better version would be to return an HTML code where there's a text area to actually enter how you feel. But let's just skip that part just to shorten the lecture. So let's see what happens if we run this one. Let's run it. Okay, so now if I go to localhost 5000 again, port 5000, it just says tell me how you feel. But then if I put a question mark with feeling equals to sad, then it's going to reply by saying don't feel bad, everything will be all right. If you do feeling as good, then it's going to say that's great, your hard work paid off. But if you do anything else, splendid, it's not going to know what you just said. It's going to just say tell me how you feel. Right? So that's how if you fill in a form on web page, there are two ways that gets passed on to the server. Sometimes it's going to call the next web page with this question mark attached. Okay, in the URL you can put this in there. So, for example, if I have a HTML page where it calls this URL with the question feeling splendid or feeling sad, then it's going to the next web page will know that the variable that's passed on is sad. It's going to respond by this. So that's how you make the web pages know what's being passed. Now, question. Would you do this to a login page? Why not? Okay, that's one thing, but what's another reason? Login page, once you type in your username and password, let's say those two information gets passed on like this. What goes wrong? You don't see a problem with that? No? Okay, well, that's going to be horrible because not only your username is known, you also have your password being out in the open. Yeah, your password be out in the open. You know, there are traffic sniffers out there that can sniff which information is being passed around, right? Even if it's an HTTPS one, these won't be secured. It won't be encrypted. It'll be pure plain text when these are sent. So other people can sniff it and actually figure out what your password was. That's going to be terrible. Okay? Now, guess what? There are still web pages that does this. I was shocked. Last winter, this year winter, I was getting some. I bought an online defensive driving course, and I typed in the username and password on it, and the password was like in plain text. It was right as the get method. So get method is kind of bad if you think about the security issues. All right, so. So let me show you this other method, which is what's called a post. Okay, and with the post, let me show you how to use a HTML template. Okay. All right. So let me start out by showing you an HTML template, and I'll just copy the template from here. So I have doc type, HTML, body, h1, and I'll just delete all the contents can be gone. Okay. So let's say you have this, and I'm going to make it really simple. Let's say H1, upload your file. So like this, and then you want to put a form with method equals to post. Now, if you wanted the form to pass the information with the get, the other one, the question mark, you change this to get, and that's how so there are two ways for the web page to pass the information that you entered, and you should always use post. Unless it's a very simple one, try to use the post one because that one does get encrypted, not as plain text. Okay, and there's something called encoder type. Now, what I'm trying to do is I want to have a very simple file upload, so that you can ask your friends to upload their files on this web page. And it should be multi-part form data. Usually you don't have to put this, but if you're uploading a file, you have to put this ENC type as this. Okay. And then you have input type equals to file. You have to say the file should be uploaded here, right? And name should be file. And this one is for the Python to know the file name. Okay. And then we're going to put a button type equals to submit, so that when you click the button, it will try to submit. Okay. And then you have upload, and then close the button, and then form. And close the form. Okay, let's save this as on the desktop. I'll put it as index2.html, and so where is it? Index2 here. So if you do this, then you can choose a file, and you can upload that by clicking upload. Okay, so that's basically this template file. But now I want to print what file was uploaded, so I'm going to go back and add another one, which is to say div class equals to files, and this just gives you an object for other JavaScript or PHP or other computer programs to interact with this. So div just means like the following area of the HTML code is going to be called class files. So if you want to have access to this area, refer to me as files class. That's basically what you're telling. Okay, and then you want to say uploaded files as h2, and then you do. Now comes special code. This is not HTML. If you say if uploaded files, and what this is what's known as the Jinja code. Okay, and that this is like one of the languages that Flask uses to interact with the HTML. Okay, so when Flask server looks at this template and looks at this, it will execute these commands, and you can do for loops and if-thens with Jinja. So what we're going to do is if there is uploaded files, I'm going to have an unnumbered list. UL means unnumbered list. Okay, and then you're going to do Jinja. For a Jinja command, it's always brace with the percent and percent with brace. So anything that's between those two, Flask server program will read it and process it as a Jinja command. Okay, for file in uploaded files, percent that. Okay, and then you're going to do list item, and then file. Okay, and then this one this one is another marker with a double curly brace. And this is an area where the Flask knows how to replace. So you can replace these items directly from the Flask Python code, and these are something that's executed by the Flask server. So there's a difference between those two. So you have to know the difference between double braces and brace percent, okay? All right, so and then I'm going to close the list item, and then you should also close the end for. So here, percent end for. Yeah. Unfortunately, Jinja doesn't have this luxury of indentation, so you have to tell Jinja exactly which part that you have to loop over. So you have to mark the end of the for loop here. Okay, and then you have to enclose the unnumbered list. And then if it's not true, then you put else. You just say p no files uploaded yet. Okay, and then enclose p. Okay, and then you have to also end if. Again, unlike Python, you don't have indentation, so you have to mark the end of the if and end of for. Okay. All right, so you have end if, and then we have div enclose. So this much will be the file area that Python code will know how to interact with, and then we just enclose the body and HTML, so everything's done. Okay. So that's going to be our HTML template. Now, if you just load this as a normal file, it's not going to be able to process the Jinja codes because it's not served up by the Flask. So if you just do this, now it has all these things that it doesn't know what to do. Okay? However, when Flask looks at this file and serves up this, it's going to process these and replace it by some other HTML codes. So it's going to be a functional thing. Okay? All right, so now let's go over here and then start writing the Python codes for it. So what we are going to do is we're going to do here in the app decorator, we're going to add methods equal to get and then post. Okay, and this allows the Flask to know that this web page that we are just making not only has the get method, which interacts by doing request get, but it also has the post method. Okay, so the post method is the other one that's used for uploading files. Okay, and then we will have to put a local directory to upload the files. So let me see. Let's just make a. Let me see. Let's go up. Do I have a temp directory? No. Okay. I'll just make a temp 2. Okay. So let's make a new directory. New folder temp 2. Okay. And then I'm going to copy that address here and uploads should be this folder or this. Okay, and then we're going to do the following. We'll have to erase all of these and say if request dot method equals to post, if the post method is requested, then if file not in request.files, then no, I don't need. Okay, sorry. I'll just do this. File equals to request.files of the file. So whatever you put into that web page, when you click upload, that file name is going to be grabbed and passed on to this Python code by the request.files file. Okay, and then and this file right here is this name file. Okay, so maybe I should have. Okay, it's okay. And then what we're going to do is we're going to take that file and we're going to do file.save and the uploads plus and then plus uploaded file.file name. Okay, sorry. File.file name. Okay. What's wrong with this? Oh. Uploads. All right. Okay, and that's it. Okay, so now we're going to do files equals to os.list directory of uploads. Okay, and then we're going to do return render template and render template. And here's what's wrong? Oh, I have to import OS. Sorry, import OS. Okay. All right. Okay. Good. So we have to return render underscore template. Oh, but I have to import that as well. Okay. Render underscore template. Okay. And then you just have to put this file name in there. So sorry for going over time a little bit. We're almost there. Okay, it's in here. R is index 2.html. Okay, and that's it. Oh, and then uploaded files as files. Yeah, so I made the list of files. The Python loads up the list of files and passes on to the template as this variable, uploaded files. And the template, when it looks at this, it looks at the uploaded files and prints everything up. Okay? All right, so now you have a template that gets served. Let's see how it works. Let's go to the local host without the feeling sent. I have to run it. So let me change this. Run this again. Okay, and then now we can do this. Okay, I'm back to my office because I couldn't finish this in class. I was in a bit of a hurry and I made two mistakes. So one was that in line number 9, I had it as parentheses. It should have been bracket because this request.files would be a dictionary, not a function. And another problem is that when I had the template file in the desktop, you can't put it in there. You have to put it in the templates folder. So what you have to do is you have to go to the folder where you have the Python file, the Flask file in there, and you have to make this templates folder in there. Where did it go? Yeah, this templates folder, and only in there you can put your templates, and it's going to process correctly. Now there is a way to change the directory name with something else. You can look it up for the Flask manual. It's not that hard. but the easiest thing to do would be to make a templates folder, note the S at the end, and put your template here. So you can see that this template is the same thing that I showed you before. All these commands not processed by Flask. This is its original form. This is the Jinja commands. But now if you run it in Flask, so let me run it in Flask. So run the Flask, and then I reload. So this is the current file. I already tried one here. But you can add more files. You can just put other files in there. You can upload. Then that file, it gets uploaded. If I go to the upload folder, I had it as temp2, I believe. Temp2. So you can see both files are uploaded. So you can imagine that this web page could be on a server where you just choose some file to upload, and you have a very easy way for other people to upload files that you want to receive without having to go through an email. So it's a very simple kind of app, but I think this demonstrates how you can use Flask. Okay, hopefully that was a good enough introduction for Flask, and there are many other use cases, so try to figure out more Flask by watching other videos and reading other articles. That's all for today.